Okay, for the second question, find the exact length of the curve x equals to 1 over 3 times square root y times y minus 3 bracket for y is smaller than and equals to 16 and bigger than and equals to 4. So this curve here has the form x equals to this. But for some previous questions and some other questions asking us to find the arc length of the curve, we have the form y equals to fx, not x equals to fy. So for example, y equals to maybe 2 over 3 x minus 1 to the power of 2 over 3. It asks you to find the arc length of the curve, and we can just use this formula, 1 plus dy over dx square dx. But for this question here, but for the second question, we don't have this form y equals to fx. We have x equals to fy. So we need to change this formula a little bit. So if x equals to fy, then s equals to integrate a to b 1 plus dx over dy derivative and dy. So this is our formula we need to use to solve this question. Okay, so first, we know that the lower bound is 4, so we just plug 4 into this formula. So a equals to 4, and b equals to the upper bound is 16, so b equals to 16, and we copy down the formula, 1 plus dx over dy square dy. Okay, now we need to find the derivative of this curve, and if we can find the derivative, and then we calculate the integrate, and then we can get the answer. So we first need to find the derivative of this original curve, y minus 3. So we need to simplify this. What I do is I simplify this. So multiply by y minus 1 over 3 square root times 3. So here x equals to 1 over 3. We change square root of y to y to the power of 1 over 2 times y minus 1 over 3, and 3 cancel out, so we only get square root of y. And then here y to the power of 1 over 2 times y equals to y to the power of 1 over 2 plus 1, which is equal to y to the power of 3 over 2. So we get x equals to 1 over 3 y to the power of 3 over 2 minus, we change this square root to y to the power of 1 over 2. Okay, so then we get this original curve, and we need to find the derivative of this. So dx over dy equals to, we keep the constant unchanged, so 1 over 3, and we need to find the derivative of y to the power of 3 over 2. So we put 3 in the front at here, and we need to 3 over 2 minus 1. Then minus, we put 1 over 2 in the front, and 1 over 2 minus 1. And then we get 1 over 3. Okay, so we cancel out 3 and 3 at here. Yeah, so we get 1 over 2 y, and 3 over 2 minus 1 is 1 over 2, minus 1 over 2 y. 1 over 2 minus 1 is minus 1 over 2. Okay, so then we need to change a little bit, and we can get the arc length. Okay, so for this one, it equals to 1 over 2 times y to the power of 1 over 2 minus 1 over 2 y to the power of 1 over 2 equals to 1 over y to the power of positive 1 over 2 here. So we get y to the power of 1 over 2, 1 over y to the power of 1 over 2. Okay, then dx over dy, so dx over dy equals to, so y to the power of 1 over 2 is just square root of y over 2 minus y to the power of 1 over 2 is square root of y times 2, 1 over 2 times square root of y. So this is our derivative that we need to find, and then we just need to plug this derivative in our formula. So this is our formula, dx dy to dy, and then we just need to plug this here into dx over dy. So we get 1 plus square root of y minus square root of y over 2 minus 1 over square root 2 times square root of y square dy. Okay, and now we have the form a minus b square equals to a square times plus 2ab times b square. So we simplify this, and we get square root 1 plus, so the square of square root y is equal to y, and the square of 2 is equals to 2, and 2 times square root of y over 2 times 1 over 2 times square root of y equals to, we cancel square root of y and out, and we cancel 2 out, so we get 1 over 2. So we minus 1 over 2 here, and plus 1 over square of 2 square root of y is 4y dy. Okay, so we combine the